Somewhere beyond the final glow of the Milky Way, beyond the last recognizable constellation, there are regions of space so empty that entire galaxies could disappear inside them without a trace. Darkness stretching across hundreds of millions of light years. No stars, no planets, no light, just silence expanding forever in every direction. And according to modern cosmology, these empty regions may be more dangerous than black holes. For centuries, humanity feared monsters in the sky. Ancient civilizations imagined dragons swallowing the sun. Modern science replaced those myths with black holes, collapsing stars so dense that even light cannot escape their gravity. We turned them into symbols of cosmic terror, invisible mouths hidden inside spacetime itself. And honestly, black holes deserve their reputation. A single black hole can tear apart stars, bend time, and trap anything unfortunate enough to cross its event horizon. Near one, the laws of physics begin behaving like nightmares. Time slows, light curves, matter stretches into ribbons thinner than atoms. Every instinct inside us screams that these objects are the ultimate danger waiting in the universe. But there is a disturbing problem with that fear. At least black holes can be understood. Scientists can detect them, measure them, photograph them. Their gravity leaves fingerprints across the cosmos. We know how they form, how they evolve, and what happens near them. Terrifying as they are, black holes still obey the rules of physics humanity understands. The real nightmare may be something far quieter. Because scattered across the universe are regions where galaxies vanish almost entirely. Places so empty that if you stood inside them, the nearest galaxy might be hundreds of millions of light years away. No glowing nebulae, no clusters of stars lighting the darkness. Just an ocean of cosmic nothingness, so vast that the human mind struggles to comprehend it. These are cosmic voids. And unlike black holes, voids do not violently announce themselves to the universe. They do not consume stars in explosions of radiation. They do not distort spacetime with dramatic collisions. They simply exist as absences, enormous wounds carved into the large-scale structure of reality itself. But the deeper scientists study these voids, the stranger they become. Because empty space is not supposed to behave like this. Some voids are so massive that entire superclusters of galaxies could fit inside them and still disappear into darkness. Others appear to influence the motion of galaxies across unimaginable distances. And hidden inside the vacuum of space itself may be forces capable of tearing the universe apart forever. This is where the story stops feeling like astronomy and starts feeling like cosmic horror. Because the greatest danger in the universe may not be violent objects collapsing inward. It may be emptiness itself. A silent force slowly stretching galaxies apart, isolating stars, erasing structure, and pushing the cosmos toward a future dominated not by matter, but by nothingness. At first glance, emptiness does not sound dangerous. Human beings evolved to fear movement, noise, predators, and catastrophe. We fear things with teeth, fire, collapse, impact. Our brains are designed to recognize threats through action. But the universe does not always destroy through violence. Sometimes it destroys through silence. Imagine drifting through space for billions of years without encountering a single star. No sunrise, no heat, no signal, no evidence that life ever existed anywhere at all. Inside a cosmic void, the universe begins to feel less like a place and more like abandonment. And yet, these regions are real. Astronomers mapping the universe discovered that galaxies are not spread evenly through space. Instead, they form immense filaments and clusters surrounding gigantic empty regions that stretch across unimaginable distances. The cosmos resembles a web, with glowing islands of matter surrounding oceans of almost perfect nothingness. The terrifying part is not merely their size. It is what they imply. Because emptiness should not behave this way. According to everything human intuition tells us, nature fills gaps. Gravity pulls matter together. Stars form from clouds of gas. Galaxies merge into larger structures over cosmic time. The universe should trend toward organization, toward connection, toward structure. And yet the deeper scientists looked into reality. The the more they discovered enormous regions where structure appears to be dissolving. As if the architecture of the universe itself is slowly coming apart. This creates a contradiction at the heart of modern cosmology. Black holes represent extreme concentration, infinite density compressed into tiny regions of spacetime. Cosmic voids represent the opposite extreme, vast stretches where matter barely exists at all. One is overwhelming presence, the other is overwhelming absence. But strangely, absence may be more powerful. Because black holes destroy locally, voids reshape the universe itself. Galaxies near them drift away, light crossing them changes. Entire regions of space expand faster than scientists once believed possible. Some physicists now suspect that the emptiest regions in existence may hold clues to dark energy, the mysterious force accelerating the expansion of the cosmos. In other words, the universe may not be dominated by matter. It may be dominated by emptiness. And that idea changes everything. Because if empty space possesses energy, if nothingness itself can influence reality, then the void is not truly empty at all. Beneath the silence may exist forces humanity barely understands. Invisible pressures stretching spacetime apart on scales too vast for human intuition to grasp. The deeper we explore these regions, the stranger they become. Inside the void, galaxies vanish. Inside the void, distance loses meaning. Inside the void, even time begins to feel irrelevant. And perhaps most unsettling of all, the void forces humanity to confront a possibility we rarely consider. Maybe the universe is not a stable structure held together by stars, gravity, and matter. Maybe those things are temporary exceptions, brief islands forming inside an ocean of expanding darkness. Maybe creation is not the natural state of reality. Maybe emptiness is. That possibility transforms the universe from a place of order into something far more fragile. Because if the cosmos is slowly being pulled apart by the growth of emptiness itself, then black holes are not the greatest threat facing existence. They are merely distractions. Visible monsters hiding a far deeper horror. A horror with no shape, no sound, no surface, only infinite silence stretching between the galaxies. And somewhere inside that silence lies a question that may redefine humanity's understanding of existence itself. What if the universe is not held together by matter, but slowly torn apart by nothing? Human beings rarely think about emptiness as an active force. We imagine nothingness as passive, harmless, irrelevant. Yet every major discovery in modern physics has pushed us toward a deeply uncomfortable realization. The vacuum of space is not truly empty. Even in regions stripped of stars and galaxies, quantum fluctuations still ripple beneath reality. Particles appear and vanish. Energy emerges from silence itself. The void is not dead, it is restless. That changes the emotional meaning of the cosmos entirely. Because suddenly, those dark regions between galaxies no longer resemble simple gaps in the universe. They resemble frontiers where the laws of reality become uncertain. Places where causality, energy, and spacetime may behave differently than expected. Black holes frighten us because they represent extremes of gravity. Voids may frighten us for the opposite reason. They reveal what reality looks like when structure disappears completely. And if structure can disappear on the scale of galaxies, then a far more terrifying question emerges. Could the universe itself eventually follow? Could everything humanity has ever known, every civilization, every star, every memory, every living mind, be temporary patterns destined to dissolve back into cosmic silence? Before we can answer that, we first need to understand why humanity became obsessed with black holes in the first place. Because long before scientists discovered the terrifying emptiness between galaxies, black holes had captured the human imagination. They became symbols of cosmic death, darkness, and the violent limits of physics itself. To understand why the void is even more unsettling, we first need to confront the monsters humanity already fears. Humanity has always feared the dark. Long before telescopes existed, ancient civilizations looked into the night sky and imagined monsters hiding beyond the stars. Darkness represented uncertainty, death, the unknown edges of existence itself. Every culture created myths about cosmic forces, swallowing worlds, devouring suns, or dragging souls into eternal oblivion. Then modern science arrived. And somehow, reality became even more terrifying than mythology. In the 20th century, physicists uncovered the existence of objects so extreme that they appeared to break the universe itself. Regions where gravity became infinitely powerful, places where time slowed, light vanished, and known physics collapsed into mathematical chaos. These objects would eventually become known as black holes, and almost immediately, they captured the imagination of humanity. Because black holes feel like the perfect cosmic nightmare, they are invisible predators drifting through space-time. You cannot touch them, negotiate with them, or escape them once you cross a certain boundary. They transform stars into ruins and twist the structure of reality around themselves. Even their name sounds absolute, final. A black hole is not merely an object. It is the idea of disappearance itself. But strangely, our fear of black holes also reveals something deeply human. We fear them because we understand them. At least partially. That may sound absurd. After all, black holes remain among the strangest phenomena in existence. Yet despite their terrifying nature, they obey rules. They can be described through mathematics, predicted through observation, simulated through equations. Humanity may not fully understand what happens inside a black hole, but we understand enough to give shape to our fear. And fear becomes easier to manage once it has a shape. The story truly begins with Albert Einstein. In 1915, Einstein introduced the theory of general relativity, a revolutionary idea suggesting that gravity is not simply a force pulling objects together. Instead, gravity emerges because massive objects bend spacetime itself. Planets orbit stars because they follow curves in the fabric of reality. Space and time are not separate things. They form one interconnected structure. At first, even Einstein struggled to accept the strange implications of his own equations, because hidden within them was a terrifying possibility. If enough matter collapsed into a sufficiently small region, spacetime would curve inwards so violently that nothing could escape. Not matter, not energy, not even light itself. For years, many scientists believed such objects could not truly exist. They seemed too bizarre, too catastrophic. Yet as astronomy advanced, evidence began to accumulate. Massive stars could collapse after death, compressing their cores beyond any known limit. The universe was not merely allowing black holes to exist. It was creating them constantly. Suddenly, black holes transformed from mathematical curiosities into physical realities scattered across the cosmos. And the deeper scientists looked, the stranger they became. Imagine approaching a black hole. From a distance, it might appear calm, even silent. But hidden around it lies a boundary known as the event horizon. This is the point of no return. Once anything crosses this invisible surface, escape becomes impossible because the escape velocity exceeds the speed of light itself. Inside that boundary, every possible future leads inward, toward the singularity, a place where density becomes infinite and the known laws of physics stop functioning entirely. Human language struggles to describe what this means because singularities represent more than destruction. They represent the breakdown of understanding itself. Our equations divide by zero. Space and time lose their normal meaning. Cause and effect begin to unravel. Black holes do not merely threaten matter, they threaten comprehension. And yet, paradoxically, they remain understandable enough for scientists to study. We know what happens near an event horizon. We can calculate gravitational effects with extraordinary precision. We understand how black holes warp light into glowing rings visible across galaxies. In 2019, humanity even captured the first image of one, a burning halo surrounding a dark center, suspended in cosmic darkness. For the first time in history, humanity looked directly at one of the universe's greatest monsters. And it looked exactly like physics predicted. That moment carried profound psychological significance. The image confirmed something powerful. Even the universe's most terrifying objects still obey hidden order. Black holes are not supernatural. They are consequences of natural laws pushed to their limits. But understanding them does not make them less horrifying. Because near a black hole, reality itself becomes hostile. Time dilation means that gravity affects time differently depending on proximity. The closer you move toward a black hole, the slower time passes relative to distant observers. A person falling toward one might experience minutes, while thousands of years pass elsewhere in the universe. Entire civilizations could rise and vanish, while someone drifts near the event horizon. Black holes turn time into something flexible, something unstable. Then there is spaghettification, one of the most violent processes ever predicted by physics. Gravity near a black hole becomes so uneven that different parts of an object experience drastically different forces. Your feet might feel stronger gravity than your head. The result is catastrophic stretching, pulling matter into thin atomic strands before destruction becomes complete. The universe contains many ways to die. Few are more terrifying. And still, black holes continued becoming stranger. In the 1970s, Stephen Hawking introduced a discovery that shocked the scientific world. According to quantum mechanics, black holes are not entirely black. Tiny quantum fluctuations near the event horizon allow them to emit faint radiation, now called Hawking radiation. Over unimaginable timescales, this means black holes slowly evaporate. That idea changed everything. Because suddenly, black holes were no longer eternal cosmic prisons. Even they could disappear. Given enough time, they would fade into the darkness alongside everything else. This creates one of the strangest contrasts in modern physics. Black holes appear invincible, yet they are temporary. They seem like the ultimate destroyers, yet they themselves can be destroyed by the passage of time. The universe contains mechanisms even more powerful than gravity. And this is where our fear becomes psychologically revealing. Human beings instinctively fear visible threats. We fear explosions more than erosion, predators more than silence. A black hole terrifies us because it behaves dramatically. It consumes, distorts, destroys openly. Our minds can emotionally engage with that kind of danger because it resembles the threats evolution prepared us to recognize. But emptiness is different. A void does not chase you. It does not roar, explode, or collapse stars into fire. It simply expands. Quietly, indifferently. That makes it harder for the human brain to process. We are uncomfortable with nothingness because nothingness offers no clear target for fear. Yet some physicists now suspect that the largest forces shaping the universe may emerge not from massive objects, but from empty space itself. And compared to that possibility, black holes begin to look almost comforting. At least they remain localized, finite, contained. A black hole can destroy a solar system, perhaps even a galaxy under extreme conditions. But the universe survives around it. Stars continue burning, galaxies continue evolving, life continues existing elsewhere in the cosmic ocean. Black holes are terrifying interruptions inside reality. But what if emptiness is woven into reality itself? What if the silent regions between galaxies are not passive gaps, but active forces reshaping the cosmos on scales beyond human imagination? Because while black holes dominate popular imagination, astronomers eventually discovered something even stranger hidden between the stars. Not objects, not explosions, not monsters, but enormous regions where almost nothing exists at all. And those regions may ultimately prove far more dangerous than black holes ever were. For most of human history, the universe appeared full. Everywhere astronomers pointed their telescopes, they found stars, galaxies, glowing clouds of gas, and immense rivers of light stretching across the darkness. Even when the cosmos seemed terrifying, it still felt populated, structured, alive. Humanity imagined the universe as an endless ocean filled with celestial objects drifting through infinite space. But then scientists began mapping the cosmos on scales larger than anyone had ever attempted before. And what they discovered changed the emotional meaning of the universe forever. Because beyond the galaxies, beyond the clusters, beyond the bright architecture of the observable cosmos, astronomers uncovered something deeply unsettling. The universe was not full. Most of it was empty. Not ordinary empty. Impossible empty. The discovery began quietly during the second half of the 20th century, when astronomers started measuring the positions of galaxies across enormous distances. Before then, humanity possessed only fragmented glimpses of the larger cosmic structure. Galaxies appeared scattered somewhat randomly, like islands across a dark ocean. But as surveys improved, a hidden pattern slowly emerged from the data. Galaxies were not evenly distributed at all. Instead, they gathered into colossal filaments stretching across hundreds of millions of light years. Vast walls of galaxies connected to dense clusters, forming structures so enormous they surpassed anything the human mind evolved to comprehend. It was as though the universe possessed a gigantic skeletal framework, invisible from smaller perspectives. And surrounding that framework lay enormous gaps. At first, scientists assumed these regions simply had not been mapped correctly. Perhaps the telescopes were missing faint galaxies. Perhaps the surveys contained errors. Surely space could not be that empty. But the evidence kept growing. The gaps were real. Entire regions existed where galaxies almost completely vanished. This revelation transformed cosmology overnight. When researchers visualized the large-scale structure of the universe, it no longer resembled random chaos. Instead, it looked hauntingly organic, a vast cosmic web. Bright threads of matter surrounded by gigantic bubbles of darkness, extending across unimaginable distances. The emotional impact of this discovery is difficult to overstate. Human beings instinctively associate emptiness with absence, a cave without life, a silent room, an abandoned city, but cosmic voids shattered ordinary intuition because their emptiness operated on scales beyond human emotional processing. These were not gaps between stars, they were gaps between entire regions of existence. Places where thousands of galaxies should have existed, but did not. One of the most famous examples is the Boötes void. Discovered in 1981, the Boötes void immediately became one of the strangest structures ever observed in the cosmos. Spanning roughly 330 million light-years across, it is so enormous that light itself requires hundreds of millions of years to travel from one side to the other. To understand that scale, imagine shrinking the Milky Way galaxy to the size of a grain of sand. Even then, the Boötes void would feel impossibly large. Thousands of galaxies could fit inside it comfortably. Entire galactic civilizations could evolve, rise, and disappear within its darkness without ever reaching the edge. Yet despite its enormous volume, astronomers found almost nothing there. Only a tiny scattering of isolated galaxies drifting through overwhelming emptiness. The discovery felt wrong. Nature rarely creates perfect absences. Forests fill open land, gravity gathers matter together, cosmic gas collapses into stars. Everywhere scientists looked, the universe demonstrated a tendency towards structure and formation. Except here. Inside the void, structure appeared to fail completely. And the Boötes void was not alone. Astronomers soon uncovered many others: the local void near our own galaxy, the Eridanus supervoid, and countless smaller regions woven throughout the cosmic web like invisible wounds. Some stretch across hundreds of millions of light years. Others merge into even larger underdense regions whose true boundaries remain uncertain. The deeper humanity mapped the cosmos, the more unsettling the pattern became. Matter was not the dominant feature of the universe. Emptiness was. This realization fundamentally altered humanity's perspective on existence itself. For centuries, civilization focused on the visible universe because visibility creates emotional meaning. We build stories around stars, around galaxies, around explosions and collisions and light. Human consciousness naturally centers itself around things. But cosmic voids forced scientists to confront the terrifying importance of nothing. Because on the largest scales imaginable, the universe is defined less by what exists, and more by what does not. Imagine floating inside one of these voids. Not near the edge where distant galaxies still glow faintly across the darkness. Deep inside, hundreds of millions of light years from meaningful structure, the night sky would become almost completely black. Entire constellations would vanish. The nearest galaxies might appear as tiny isolated sparks, separated by incomprehensible distances. There would be no sense of belonging to a larger cosmos. Only isolation. An observer born inside such a region might never even realize the wider universe exists at all. That possibility introduces a disturbing philosophical idea. Human understanding of reality depends heavily on perspective. We discovered galaxies because we inhabit a galaxy-rich region of space. We discovered the cosmic web because enough light reaches us to reveal it. But what if consciousness evolved deep inside a void? Civilizations there might conclude the universe is static, empty, and lifeless beyond their local surroundings. They could spend millions of years searching for evidence of a larger cosmos and find only silence. In this way, cosmic voids do not merely challenge astronomy. They challenge meaning itself. Black holes at least create visible consequences. They bend light, consume matter, generate violent energy. Even in destruction, black holes remain active participants in cosmic evolution. Their presence announces itself dramatically across spacetime. Voids behave differently. They erase through absence. No explosions mark their territory. No gravitational monsters dominate their centers. Instead, they stretch outward in quiet indifference, regions where the architecture of reality seems unfinished or abandoned. And strangely, their silence may be more disturbing than violence. Human beings can emotionally process catastrophe because catastrophe feels temporary. An explosion begins and ends. A predator attacks and retreats. Even black holes consume matter through recognizable physical processes, but emptiness offers no resolution, no climax, no confrontation. Only endless distance. This psychological contrast explains why cosmic voids feel uniquely unsettling once understood. A black hole represents concentrated danger, a localized tear in spacetime. A void represents something colder, the gradual disappearance of connection itself. Inside crowded galaxy clusters, gravity binds enormous structures together. Galaxies collide, merge, and ignite waves of star formation. Supermassive black holes erupt with energy brighter than entire galaxies. Matter dances violently across billions of years, creating a universe that feels alive and dynamic. Inside a void, almost none of that happens. Stars become isolated. Galaxies drift apart. Darkness dominates everything. The universe grows quiet. And according to modern cosmology, those quiet regions may slowly be winning. Because cosmic expansion does not affect all regions equally, voids expand faster than dense clusters, stretching emptiness outward across the cosmic web. Over unimaginable timescales, matter itself may become increasingly isolated as the universe continues expanding. Galaxies will drift farther apart. Light will struggle to bridge the growing distances. The observable universe will gradually fragment into lonely islands surrounded by expanding darkness. In other words, emptiness is not static. It spreads. That possibility transforms voids from passive regions into active participants in the future of the cosmos. They are not merely empty spaces between galaxies. They are evolving structures shaping the destiny of reality itself. And yet, the deeper scientists investigate these voids, the stranger they become. Because according to quantum physics, truly empty space may not actually exist. Even in the darkest regions of the universe, something still stirs beneath the silence. Invisible fluctuations ripple through spacetime. Particles appear and vanish. Energy emerges from apparent nothingness. The vacuum itself behaves less like emptiness and more like a hidden ocean of unstable activity. Which raises a terrifying possibility. What if the emptiest places in the universe are not dead at all? What if they are hiding forces humanity barely understands? Because once scientists began studying the physics of emptiness itself, they discovered something even stranger than the voids surrounding the galaxies. They discovered that nothingness may be one of the most dangerous things in existence. Human intuition tells us that empty space should contain nothing. No matter, no energy, no movement, just silence. For centuries, this idea seemed obvious. Ancient philosophers imagined the vacuum as a perfect void, a complete absence of existence itself. Even early scientists treated emptiness as a passive stage where the real events of the universe unfolded. Planets moved through it, stars burned inside it. Galaxies drifted across it, but space itself appeared lifeless, an invisible backdrop surrounding the visible cosmos. Then quantum physics arrived. And suddenly, emptiness became one of the strangest things humanity had ever discovered. Because according to modern physics, truly empty space may not exist at all. At first, this sounds impossible. How can nothing contain something? How can emptiness possess activity, energy, or structure? The contradiction feels almost linguistic, as though physics itself has begun violating common sense. Yet experiment after experiment forced scientists toward a deeply unsettling conclusion. The vacuum is alive. Not alive in the biological sense, not conscious, not aware, but active, restless. Filled with invisible motion, hidden beneath the apparent stillness of reality. To understand why this matters, imagine removing everything from a region of space. Every atom, every photon, every particle of dust, every trace of radiation. At the classical level of physics, the result should be absolute emptiness, a perfect vacuum, nothing remaining at all. But quantum mechanics refuses to allow such stillness. At the smallest scales imaginable, uncertainty governs reality itself. Particles cannot possess perfectly fixed positions and energies simultaneously. Tiny fluctuations ripple continuously through spacetime, causing brief eruptions of activity even in complete darkness. Pairs of particles spontaneously appear, exist for impossibly small fractions of time, and then annihilate each other again almost instantly. These are called virtual particles, and they emerge everywhere. Even now, as you sit watching this documentary, countless quantum fluctuations are flickering invisibly through the empty space around your body. The vacuum is not silent. It seethes beneath perception like an invisible storm hidden underneath reality itself. This realization fundamentally changed the meaning of nothingness. In classical physics, emptiness meant absence. In quantum physics, emptiness becomes unstable. The vacuum behaves less like an empty container and more like a hidden ocean of probabilities, continuously boiling beneath the surface of existence. Some physicists compare it to foam bubbling at microscopic scales, a concept known as quantum foam. At unimaginably tiny distances, spacetime itself may fluctuate violently, twisting and vibrating with chaotic energy. Reality is not resting. Reality is trembling. And strangely, the emptier a region becomes, the more mysterious this hidden activity appears. This creates a profound philosophical contradiction. Human beings associate emptiness with peace, silence, stillness, Yet modern physics suggests that absolute emptiness may be fundamentally impossible because existence itself resists total stillness. The universe appears unable to remain perfectly calm. Even nothingness vibrates. Even darkness contains motion. And that realization becomes even stranger once scientists begin measuring the energy hidden inside empty space. According to quantum theory, every field in the universe possesses a lowest possible energy state called zero-point energy. Even at absolute zero temperature, where all ordinary motion should cease, quantum systems still retain faint residual energy because uncertainty prevents total stillness. In other words, the vacuum itself contains energy even when everything else is removed. That idea sounds abstract, but its consequences are enormous. Because if empty space contains energy, then emptiness is not passive. It can influence matter, alter spacetime, and potentially shape the evolution of the universe itself. Suddenly, the vacuum transforms from a blank background into an active participant in cosmic reality. Some experiments have already confirmed hints of this strange behavior. One famous example is the Casimir effect. When two metal plates are placed extremely close together inside a vacuum, quantum fluctuations between them become restricted compared to the surrounding space. The result creates a measurable force pushing the plates together, generated purely by the structure of empty space itself. Nothingness can exert pressure. Pause for a moment and consider how strange that truly is. The empty vacuum between objects can physically affect reality. This realization shattered one of humanity's oldest assumptions, that existence is defined primarily by matter. Modern physics increasingly suggests that invisible fields and hidden vacuum energies may be more fundamental than the stars and galaxies we actually see. Matter may be secondary. Emptiness may come first. And somewhere inside this unsettling possibility lies one of the greatest mysteries in cosmology: dark energy. In the late 20th century, astronomers discovered that the expansion of the universe is accelerating. Galaxies are not merely drifting apart from the momentum of the Big Bang. Something is actively pushing spacetime outward faster over time. This invisible force became known as dark energy, and to this day, scientists still do not fully understand what it is. But one possibility terrifies physicists more than most people realize. Dark energy may emerge from the vacuum itself. The emptiness between galaxies may contain hidden energy woven directly into spacetime, causing the universe to expand faster and faster across cosmic time. If true, then the largest force shaping the destiny of reality does not come from stars, black holes, or galaxies. It comes from empty space. And the deeper physicists explored this idea, the more unstable the vacuum began to appear. Because according to some quantum theories, the universe may currently exist in what is known as a false vacuum state. To understand this, imagine a ball resting inside a shallow valley on a mountainside. At first glance, the ball appears stable. It barely moves, everything seems calm, but hidden nearby lies a deeper valley separated by only a small barrier. If the ball ever crosses that barrier, it would fall violently into a lower energy state. Some physicists believe the universe itself may function this way. Reality appears stable because we exist inside a temporary vacuum state, but it may not represent the true lowest energy configuration possible. Beneath our universe could exist a more stable vacuum, waiting silently beneath the surface of existence. And if a transition ever occurred, the consequences would be catastrophic. The laws of physics themselves could change instantly. Atoms might no longer hold together. Chemistry could collapse. Matter could become impossible. Everything humanity has ever known would vanish as a bubble of true vacuum expanded outward at the speed of light, rewriting reality itself faster than any signal could escape. No warning, no survival, no evidence left behind. just total erasure moving invisibly through space-time. This possibility sounds like science fiction, yet it emerges directly from legitimate quantum theory. Even more unsettling, scientists do not know what could trigger such an event. It might never happen, or it may have already happened somewhere beyond the observable universe right now, racing silently outward through the cosmic darkness. And where would such instability most likely emerge? Possibly within the emptiest regions of space. Inside cosmic voids, matter becomes sparse, radiation weakens. Vast regions drift through unimaginable isolation. These environments may represent the closest approximation to pure vacuum conditions found anywhere in the universe. The same regions humanity once dismissed as harmless emptiness could actually be laboratories of hidden quantum instability. Suddenly, the void no longer feels passive. It feels dangerous. Because once emptiness itself contains energy, fluctuations, and hidden structure, the universe becomes psychologically inverted. Human beings naturally fear objects because objects appear powerful. Mountains, storms, black holes. Yet quantum physics suggests that the greatest forces shaping existence may emerge not from things, but from the vacuum surrounding them. The darkness between galaxies may possess more influence over cosmic destiny than the galaxies themselves. And perhaps most terrifying of all, humanity still does not truly understand what empty space is. We measure its effects. We model its behavior. We write equations describing its fluctuations. But beneath those equations lies a deeper mystery. Why does the vacuum possess energy at all? Why does existence refuse perfect stillness? Why does reality emerge from quantum uncertainty instead of absolute nothingness? No one knows. And until we do, the emptiest places in the universe will remain among the most unsettling frontiers in all of science. Because they may not merely contain nothing. They may contain the hidden instability capable of changing reality itself. And if that is true, then the silent voids between galaxies are not the safest places in the cosmos. They may be the most dangerous places in existence. Imagine waking up tomorrow morning exactly as you always have. The sky looks normal. Cities move with familiar rhythm. Somewhere a child laughs. Somewhere else, a star explodes millions of light years away without anyone noticing. Humanity continues its endless cycle of routines, ambitions, wars, discoveries, and dreams, completely unaware that the universe itself may already be dying. Not through fire, not through collision, not through black holes swallowing galaxies, but through a silent instability hidden inside the fabric of reality itself. And the terrifying part is this. If it began, no one would ever see it coming. For most of history, humanity imagined the end of the world as a violent event. Ancient myths described floods, celestial battles, or divine judgment descending from the heavens. Modern science replaced mythology with astrophysical disasters, asteroid impacts, supernovas, gamma-ray bursts, black holes consuming entire systems. All terrifying, all catastrophic. Yet every one of those scenarios shares something psychologically comforting. They are local. A planet dies. A star collapses. A galaxy burns. But the wider universe survives around the destruction. Vacuum decay is different. Vacuum decay does not threaten a civilization, a solar system, or even a galaxy. It threatens reality itself. The idea emerges from one of the strangest possibilities in quantum physics, that the universe may not truly be stable. Everything humanity experiences, matter, chemistry, light, time, consciousness, may exist inside a temporary quantum state balanced precariously above a deeper and more stable configuration of reality. To understand this, imagine a frozen lake hidden beneath snow. From the surface, everything appears solid, safe, permanent, but underneath lies dark water waiting silently below. One small fracture changes everything instantly. Stability disappears. the illusion collapses. Some physicists believe our universe may function the same way. The vacuum of space appears calm because we exist inside what is called a false vacuum, a state that seems stable but may actually contain hidden instability. Somewhere beneath the structure of reality could exist a lower energy state known as the true vacuum. And if the universe ever transitions into that state, existence as we know it would end immediately. Not gradually, immediately. The terrifying simplicity of this theory is what makes it so psychologically devastating. Black holes are complicated. They involve gravity, collapse, singularities, and extreme astrophysical conditions. Vacuum decay requires none of that. It could begin spontaneously anywhere in the cosmos through an ordinary quantum fluctuation. A tiny event. An invisible shift. A microscopic bubble of true vacuum forming somewhere deep in space. And then everything changes forever. Because once formed, that bubble would expand outward at the speed of light, consuming the universe faster than information itself can travel. No signal could outrun it. No civilization could detect it in advance. The moment you became aware of it, you would already be gone. Entire galaxies would vanish instantly without ever understanding what killed them. And unlike explosions or collisions, vacuum decay would not merely destroy matter. It would rewrite the laws of physics themselves. Inside the expanding bubble, the fundamental constants of nature could become completely different. Electrons might fail to bind to atoms. Nuclear forces could weaken or strengthen catastrophically. Chemistry might become impossible. Stars would no longer shine. Matter itself could collapse into forms beyond human comprehension. The universe would not burn. It would be replaced. This is what makes vacuum decay uniquely horrifying compared to every other cosmic disaster humanity has imagined. Black holes destroy within the existing laws of physics. Vacuum decay destroys the laws themselves. It does not attack structure from the outside. It removes the possibility of structure entirely. Even the word destruction becomes inadequate. Because destruction implies something remains afterward. Vacuum decay leaves no familiar universe behind. And perhaps the most unsettling aspect is that this scenario is mathematically plausible. In 2012, physicists studying the Higgs boson made a disturbing observation. Measurements suggested that the Higgs field, the invisible field giving particles their mass, may place our universe in a metastable state. Not perfectly stable, not immediately doomed, but balanced dangerously close to instability. Imagine a ball resting near the edge of a cliff. For now, it remains still. But the possibility of collapse exists permanently. That realization sent a quiet wave of unease through theoretical physics. Most scientists do not believe vacuum decay is likely anytime soon. The universe has survived nearly 14 billion years already, yet probability offers little emotional comfort once the possibility exists at all. Because even an extraordinarily unlikely event becomes terrifying when the consequences equal total erasure. And unlike black holes, there would be no dramatic warning signs. No growing darkness swallowing stars. No tidal forces distorting galaxies. No final transmission from doomed civilizations. Vacuum decay would arrive with absolute silence. A wall of rewritten reality moving invisibly through space-time. Human beings evolved to fear predators because predators can be seen. We fear storms because storms announce themselves. But vacuum decay bypasses every instinct evolution gave us. There is no visible enemy, no sound, no motion, only sudden non-existence. This creates a deeper philosophical horror hidden beneath the physics itself. Human civilization depends on an assumption so basic we rarely question it. That reality will continue behaving tomorrow the way it behaves today. Gravity will persist. Atoms will remain stable. Time will move forward. The laws of physics appear eternal, fixed beneath existence like invisible foundations supporting the universe. Vacuum decay shatters that assumption completely. It suggests the foundations themselves may be temporary, that the universe is not guaranteed, that existence rests upon invisible quantum stability humanity neither controls nor fully understands. For centuries, philosophers debated whether reality possessed meaning, purpose, or order. Science often answered those fears with reassuring predictability. Planets obey equations. Light follows measurable rules. Nature behaves consistently enough for civilizations to build knowledge across generations. But vacuum decay introduces a terrifying form of cosmic indifference. The universe may not care whether complexity survives. Consciousness may exist only because reality temporarily allows it. That possibility transforms humanity's position in the cosmos. We like to imagine ourselves protected by scale, believing the vastness of space provides safety through distance. Yet quantum instability ignores scale entirely. A microscopic fluctuation could erase trillions of galaxies equally. The universe does not distinguish between civilizations, and dust once the vacuum changes. Everything becomes fragile. Everything becomes conditional. And strangely, the emptiest regions of space may be the most dangerous places of all. Because vacuum decay is fundamentally tied to the vacuum itself. Cosmic voids represent the closest approximations to pure emptiness found anywhere in existence. Matter becomes sparse there. Radiation weakens. Gravitational interactions diminish across enormous distances. If instability exists within the vacuum, then the silent voids between galaxies may statistically provide the environments where quantum transitions become most likely. In other words, the regions humanity once dismissed as harmless nothingness could secretly be the universe's greatest threat. This creates a haunting inversion of cosmic fear. For generations, humanity looked toward violent objects as symbols of danger. Exploding stars, colliding galaxies, black holes lurking in darkness. Yet modern physics increasingly points toward a quieter possibility. The universe may ultimately be destroyed not by something massive, but by emptiness itself. And if that idea feels emotionally difficult to process, that is because the human mind evolved inside a world where emptiness rarely acts as a force. On Earth, emptiness is passive. A vacant room changes nothing. An empty field waits to be filled. But at cosmic scales, the vacuum may possess hidden structure, hidden energy, and hidden instability capable of rewriting reality itself. The void is not absence. The void is potential. Potential for creation. Potential for destruction. Potential for realities entirely different from our own. Some physicists even speculate that vacuum decay may have happened elsewhere already. Somewhere beyond the observable universe, another region of spacetime could have collapsed into a lower energy state billions of years ago. A bubble of altered physics may already be expanding outward through cosmic darkness at light speed. If so, humanity would never know. Not because the bubble is too distant, but because information cannot outrun its edge. That detail transforms vacuum decay from theoretical disaster into existential horror. It could already be happening, right now, somewhere beyond the galaxies visible to human eyes. Entire civilizations may have vanished silently without leaving evidence behind. Countless stars may already exist inside regions where our laws of physics no longer function. And the observable universe would remain calm until the final instant arrived. No warning, no preparation, no final understanding, only sudden replacement. Compared to that possibility, black holes begin to feel almost merciful. They destroy locally, predictably, slowly enough for physics to describe their behavior. They are terrifying, but they remain understandable monsters confined within the universe. Vacuum decay threatens the universe itself. It transforms reality from something stable into something temporary. And once humanity confronts that possibility, an even deeper question emerges. If emptiness possesses the power to erase the cosmos entirely, then what exactly is driving the expansion of emptiness across the universe in the first place? Because while vacuum instability threatens existence at the quantum level, another force may already be pulling the cosmos apart on the largest scales imaginable. A force hidden inside empty space itself. A force scientists call dark energy. For most of the 20th century, scientists believed they understood the future of the universe. The details remained uncertain, but the overall story appeared simple. The Big Bang had launched space outward billions of years ago, filling the cosmos with galaxies racing away from one another in every direction. Gravity, however, should gradually slow that expansion over time. Every star, galaxy, and cluster pulls on every other structure across the universe. Matter creates attraction. Attraction resists expansion. It was a cosmic tug of war. And gravity was expected to win eventually. Some physicists imagined the universe expanding forever while slowing gradually into darkness. Others believed gravity might someday reverse expansion entirely, pulling everything back together in a catastrophic collapse called the Big Crunch. But nearly everyone agreed on one assumption. The expansion of the universe should be decelerating. Then the universe revealed something terrifying. In the late 1990s, astronomers studying distant supernova explosions made a discovery so shocking that many researchers initially thought their calculations were wrong. The light arriving from ancient galaxies suggested that the universe was not slowing down at all. It was accelerating. Galaxies were moving apart faster over time. The cosmos was not losing momentum. Something was pushing it outward. That realization changed modern cosmology forever. Because according to everything scientists understood about gravity, this should have been impossible. Matter attracts matter. Large structures should gradually resist expansion across cosmic time. Yet observations revealed the exact opposite behavior. Space itself appeared to be stretching faster as the universe aged. Something invisible was overpowering gravity on the largest scales imaginable. And humanity still does not know what it is. Scientists gave this unknown force a deceptively simple name, dark energy. But the phrase hides the true emotional weight of the discovery. Dark energy is not merely another cosmic phenomenon like black holes or exploding stars. It represents a fundamental crisis in humanity's understanding of reality itself. According to current observations, roughly 70% of the universe may consist of this invisible force, while all stars, planets, galaxies, and ordinary matter combined account for only a tiny fraction of existence. In other words, the visible universe is not the dominant feature of reality. The invisible vacuum is. That idea fundamentally changes the emotional architecture of the cosmos. Human beings instinctively view matter as the foundation of existence because matter creates everything familiar. Mountains, oceans, trees, planets, human bodies, civilizations, consciousness itself emerges from organized matter. We define reality through things we can touch, see, and measure directly. But dark energy suggests the universe is governed primarily by something humanity cannot perceive at all. An invisible pressure hidden inside empty space. And the deeper scientists investigated, the stranger the picture became. According to Einstein's equations, spacetime itself can possess energy. Empty space is not truly empty, as quantum physics already suggested. Instead, the vacuum may contain an intrinsic energy woven directly into the fabric of reality. On sufficiently large scales, this energy creates repulsive effects, pushing galaxies away from one another as space expands. The terrifying implication is simple. Nothingness may be stronger than gravity. For billions of years after the Big Bang, matter dominated cosmic evolution. Gravity gathered gas into stars. Stars formed galaxies. Galaxies merged into enormous clusters connected across the cosmic web. Structure emerged from chaos because gravity pulled matter together faster than expansion could separate it. But slowly, over immense stretches of time, something changed. As galaxies spread farther apart, the influence of gravity weakened across the largest distances. Dark energy, however, did not weaken. The vacuum itself continued expanding relentlessly, stretching spacetime outward regardless of how matter resisted. Eventually, emptiness began winning. And once that process started, it accelerated continuously. This creates one of the most haunting contrasts in cosmology. Gravity represents connection. It gathers matter together, creating stars, galaxies, and the conditions necessary for life. Gravity builds structure. It transforms scattered particles into organized systems capable of memory, chemistry, and consciousness. Dark energy does the opposite. It separates. It isolates. It stretches reality itself until the distances between galaxies become almost incomprehensible. The universe is caught between these opposing forces, matter trying to hold existence together while emptiness steadily tears it apart. And according to current observations, emptiness is slowly winning the war. This becomes especially disturbing when viewed through the lens of cosmic voids. Voids are not static gaps floating harmlessly between galaxies. Because they contain relatively little matter, gravity inside them becomes weaker than in dense regions of space. As a result, dark energy dominates more strongly within these enormous empty regions, causing them to expand even faster than surrounding areas. The emptiest regions of the universe are growing the fastest. Imagine watching cracks spread across frozen ice. At first, the fractures appear small and isolated, but over time they widen, separating the solid structure into disconnected fragments drifting farther apart. Modern cosmology suggests something similar may be happening across the universe itself. Cosmic voids expand outward, while dense regions become increasingly isolated from one another. The cosmic web slowly stretches thinner. Galaxies drift apart. Darkness grows, and all of it happens silently. This silence is what makes dark energy psychologically unsettling in a way black holes are not. Black holes behave dramatically. They consume matter visibly. They bend light into brilliant halos. They announce themselves through violence and distortion. Dark energy offers no spectacle, no explosion, no visible monster moving through space. It simply changes the geometry of reality over billions of years. Quietly, indifferently, human beings rarely notice gradual destruction. We react emotionally to sudden catastrophes because evolution prepared us for immediate threats. But dark energy operates beyond ordinary intuition. It reshapes the universe slowly enough that entire civilizations rise and vanish without perceiving the larger transformation occurring around them. And yet, over cosmic timescales, its effects become absolute. Billions of years from now, galaxies beyond our local group will disappear permanently beyond the observable horizon. Their light will never reach future observers, because expansion will carry them away faster than light can bridge the growing distances. Future civilizations may look into the sky and see only darkness surrounding their isolated galaxy, unaware that countless other galaxies ever existed at all. The universe itself will appear smaller over time. It's lonelier, quieter. Dark energy gradually erases connection across cosmic scales. That possibility introduces an almost existential sadness into modern cosmology. Humanity currently exists during a rare era when the universe remains visible and interconnected enough for intelligent life to study its larger structure. We can still observe distant galaxies, measure cosmic expansion, and reconstruct the history of the Big Bang because the cosmos has not yet expanded beyond comprehension. But this window may be temporary. Future civilizations may inherit a universe where evidence of cosmic origins has vanished into darkness forever. And perhaps most unsettling of all, scientists still do not truly understand why dark energy exists. Some theories connect it to quantum vacuum energy. Others suggest entirely new forms of physics hidden beyond current understanding. A few even question whether Einstein's theory of gravity itself remains incomplete on the largest scales. Despite decades of research, humanity still cannot explain the force dominating most of the cosmos. The universe is accelerating outward for reasons we do not understand. That fact alone should deeply unsettle us, because it means the largest force shaping reality remains fundamentally mysterious. And the more scientists study dark energy, the more the cosmos begins resembling something profoundly unstable. Galaxies form only temporary islands against a growing ocean of emptiness. Gravity fights desperately to preserve structure, while expansion continuously separates everything farther apart. Matter builds. Emptiness dissolves. One creates stars. The other isolates them. And over unimaginable spans of time, the balance appears increasingly unequal. The future may not belong to galaxies, civilizations, or even black holes. It may belong to the vacuum itself. This realization transforms cosmic voids from strange astronomical structures into symbols of the universe's ultimate direction. They are not merely empty regions scattered between galaxies. They may represent previews of the cosmos's final state, a reality dominated by distance, silence, and expanding darkness. Because if dark energy continues strengthening its grip across space-time, then one terrifying possibility emerges. The universe may not end in fire or collapse. It may end in isolation. A slow unraveling where galaxies drift so far apart that the cosmos itself becomes fragmented into lonely islands surrounded by infinite emptiness. Even now, that process has already begun. The voids are growing. The distances are increasing. The architecture of the universe is stretching thinner with every passing moment. And somewhere inside that growing darkness lies another terrifying question. If emptiness continues expanding forever, what eventually happens to the galaxies trapped along its edges? Could the void itself slowly destroy the structures trying to survive against it? When humanity imagines the destruction of a galaxy, the images are always violent. Stars exploding in chains of supernovas. Black holes devouring entire systems. Galaxies colliding in colossal storms of fire and gravity. Even at cosmic scales, we instinctively imagine death as an event. Sudden, visible, loud, but the universe may possess another way to erase structure entirely, one so slow and silent that civilizations might never recognize it while it happens. Not destruction through impact. Destruction through isolation. Because cosmic voids do not merely surround galaxies. They influence them. And over immense stretches of time, that influence may become catastrophic. To understand why, imagine a galaxy not as a static object, but as part of a living cosmic ecosystem. Galaxies survive through interaction. Gravity pulls fresh gas inward from surrounding space. Smaller galaxies merge into larger ones. Interstellar matter collapses into new generations of stars. Even black holes, terrifying as they are, participate in this cycle by shaping galactic evolution through energy and motion. The universe is dynamic because matter remains connected. But near a cosmic void, those connections begin to weaken. Galaxies positioned along the edges of enormous voids experience strange gravitational effects, unlike those found inside dense galactic clusters. Instead of being surrounded by rich flows of matter and neighboring structures, they face immense regions of emptiness stretching outward across millions of light years. And emptiness changes motion. Gravity works through imbalance. Objects move according to the distribution of mass around them. In dense regions, galaxies pull one another together into clusters and superclusters, but near voids, the absence of matter creates asymmetry. Galaxies effectively experience less gravitational pull from the direction of the void, causing them to drift outward differently than expected. Astronomers sometimes describe this as a kind of repulsive effect, though technically the void is not pushing galaxies away. Instead, matter elsewhere pulls more strongly than the emptiness does. The result creates enormous flows of galaxies moving around and away from underdense regions across the cosmic web. Even nothingness can shape motion. That realization alone feels unsettling. Human intuition assumes empty space should do nothing at all. Yet cosmic voids influence galaxies precisely because they contain so little matter. Their emptiness changes the gravitational landscape of the universe itself. And over billions of years, those subtle distortions accumulate. Galaxies near massive voids gradually become more isolated. Fresh matter becomes increasingly difficult to acquire. Gas streams weaken. Interactions with neighboring systems decrease. Star formation slows as galaxies exhaust their internal fuel reserves without replenishment from the surrounding cosmos. The galaxy does not explode. It fades. This process introduces a profoundly different form of cosmic death than the violence associated with black holes. A black hole destroys actively. It tears matter apart through overwhelming gravity. Its effects are dramatic and immediate, but voids operate through absence. They do not attack galaxies directly, they simply prevent renewal. And without renewal, even the brightest structures eventually decay. Imagine a city completely cut off from the rest of civilization. No trade, no communication, no incoming resources. At first, life continues normally. Lights remain on, streets remain active, but slowly over generations, systems begin failing. Supplies diminish, buildings erode, knowledge fragments. Isolation transforms vitality into stagnation. Cosmic voids may produce something similar on galactic scales. Because galaxies are not eternal machines, they survive through constant exchange with the larger universe. Remove those connections long enough, and the galaxy gradually becomes a closed system, drifting toward entropy. Stars age and die. Fewer new stars replace them. Darkness spreads. Eventually, the galaxy enters a slow twilight state, sometimes called galactic quenching, where star formation nearly ceases altogether. The once vibrant ecosystem becomes dominated by old, dying stars glowing faintly across cosmic darkness. Not dead, but no longer truly alive either. This emotional contrast lies at the center of why voids feel uniquely disturbing. Black holes resemble predators. They consume visibly, violently, and locally. Human beings understand predators because evolution trained us to fear them, but voids behave more like abandonment. They isolate systems until decay becomes inevitable. The universe does not always kill through force. Sometimes it kills through silence. This silence becomes even more unsettling when viewed across larger scales. Entire galaxy clusters may gradually drift farther apart as voids expand between them. Over billions and trillions of years, structures once connected across the cosmic web become increasingly separated by impossible distances. Communication breaks down. Interaction weakens. Isolation becomes permanent. Eventually, even light itself struggles to bridge the growing emptiness. Imagine standing inside a galaxy billions of years in the future. The neighboring galaxies once visible across the sky have disappeared beyond the observable horizon. No evidence remains of the larger cosmic web humanity once mapped. The universe appears static, empty, and lonely beyond your isolated region of stars. Civilizations living in that era may never realize they inhabit the remnants of a once interconnected cosmos. To them, emptiness would appear normal. That possibility transforms cosmic isolation into something philosophical as well as physical. Human consciousness depends profoundly on connection. Meaning emerges through relationships, between people, civilizations, ideas, memories, and discoveries. Even science itself depends on the assumption that the universe is accessible enough for observation and understanding. But what happens when connection disappears? What happens when reality itself becomes fragmented into isolated islands, drifting forever through expanding darkness? At some point, isolation stops being a temporary condition and becomes a permanent feature of existence. And perhaps permanence is what truly makes voids terrifying. A black hole destroys quickly compared to cosmic history. Its violence eventually ends. Matter crosses the event horizon and vanishes from view, but voids continue expanding indefinitely. They widen distances, weaken structures, erase interaction. Their effects accumulate slowly enough that the universe may appear stable while actually drifting toward irreversible fragmentation. This creates a haunting inversion of life itself. Biological systems survive through exchange. Cells exchange energy, ecosystems exchange resources, civilizations exchange information, galaxies exchange matter. Across every scale of existence, vitality emerges from interaction and flow. Isolation interrupts that process. Entropy takes over. The system cools. And eventually, the structure loses the complexity necessary to sustain itself. In this sense, cosmic voids may represent more than astronomical features. They may embody a deeper principle hidden throughout nature, that separation itself can become destructive over sufficient time. The universe builds through connection. The void dismantles through distance. And the most disturbing part is that this process may already define the future of the cosmos. Even now, dark energy continues stretching spacetime outward. Cosmic voids continue growing larger. Galaxies continue drifting farther apart. The architecture of reality is slowly becoming less connected with every passing billion years. What humanity currently experiences as a richly populated universe may represent only a temporary phase between greater eras of darkness. A brief moment before isolation dominates completely. And unlike black holes, there may be no dramatic final event marking that transition. No explosion. No collapse. Only gradual disappearance. One galaxy at a time. One connection at a time. One fading light after another swallowed by distance and silence. The terrifying truth about voids is not merely that they are empty. It is that emptiness spreads. And if the expansion of isolation continues forever, then the ultimate fate of the universe may not be destruction through violence at all. It may be abandonment on a cosmic scale. A reality where every galaxy becomes trapped inside its own lonely island of stars, surrounded by darkness so vast that the very memory of a connected universe eventually disappears. And once humanity confronts that possibility, another unsettling realization emerges. Perhaps we are living during an extraordinarily rare moment in cosmic history, a brief era when the universe is still visible, connected, and alive enough to understand itself before the silence finally takes over. Imagine looking into the night sky trillions of years from now. Not millions, not billions, trillions. By then, humanity, if anything like humanity still exists, may inhabit a universe almost unrecognizable compared to the cosmos we know today. The sky that once overflowed with galaxies, clusters, and rivers of light will have transformed into something colder, smaller, quieter. Most of the universe will simply be gone. Not destroyed, not consumed, gone from sight forever. And perhaps the most tragic part is that future civilizations may never realize anything is missing at all. Right now, humanity lives during a remarkably unusual era in cosmic history. When we look into deep space today, we see evidence of a vast interconnected universe. Telescopes reveal billions of galaxies stretching across observable space. Light from ancient stars travels billions of years before reaching Earth, allowing scientists to reconstruct the history of cosmic evolution itself. We can detect the afterglow of the Big Bang. We can map the cosmic web. We can measure the expansion of spacetime and study structures so enormous they challenge human comprehension. The universe still remembers its own beginning. But this era is temporary. Because while humanity studies the cosmos itself is slowly disappearing. Every second, distant galaxies move farther away as spacetime expands. Most are already receding from us at incredible speeds. Eventually, due to dark energy, many galaxies will cross a boundary known as the cosmic horizon. Beyond that point, their light will never reach us again, no matter how long the universe survives. The galaxies themselves will continue existing, but they will become permanently unreachable, invisible forever. Imagine standing on a shoreline while islands slowly drift into an endless fog. One by one, their lights fade into the distance until the horizon becomes empty. The islands are still there somewhere beyond the mist, but eventually, no evidence of them remains. That is the future of the observable universe. And over unimaginable stretches of time, the process becomes absolute. In roughly 100 billion years, nearly every galaxy outside our local gravitational group will vanish beyond visibility. The night sky will no longer contain sprawling galactic structures scattered across cosmic darkness. Future observers may see only the remnants of their own isolated galaxy, surrounded by almost perfect emptiness. The universe will appear static, lonely, finite. All evidence of cosmic expansion will disappear from observation entirely. This creates one of the most unsettling philosophical consequences in modern cosmology. Future civilizations may become scientifically trapped. Without visible distant galaxies, they may never discover the Big Bang. They may never learn that the universe was once expanding. The cosmic microwave background radiation, the ancient afterglow of creation itself, will eventually stretch into wavelengths too faint and diffuse to detect. The universe will erase its own history. Imagine how tragic that truly is. Humanity currently understands the cosmos only because we exist during a narrow window when evidence of cosmic origins remains visible. We discovered expansion because galaxies still shine across vast distances. We reconstructed the Big Bang because ancient radiation still fills the sky. Our entire understanding of cosmology depends on temporary observational conditions. Future observers may inherit a universe stripped of those clues entirely. To them, reality may appear eternal and unchanging. They may never know a larger cosmos once existed beyond their isolated region of stars. This possibility transforms cosmic expansion into something far more profound than a physical process. The growth of emptiness does not merely separate matter, it erases knowledge itself. Darkness becomes informational. Silence becomes historical. The universe gradually loses the ability to explain itself. And perhaps nowhere is this more emotionally unsettling than in the realization that awareness itself may be temporary. Human beings often imagine consciousness as something central to existence. We build philosophies, religions, and civilizations around the idea that intelligent observers possess special significance within reality. Yet cosmology increasingly suggests that awareness may emerge only during extremely rare conditions. Life requires stars. Stars require galaxies. Galaxies require matter dense enough to collapse under gravity before expansion tears everything apart. Consciousness may exist only during a brief middle chapter in cosmic history, a temporary flicker of awareness surrounded by immense eras of darkness before and after. For billions of years after the Big Bang, the universe was too hot and chaotic for life. In the distant future, it may become too cold and isolated. Between those extremes exists only a narrow habitable era when complexity can flourish long enough for intelligence to emerge and ask questions about existence itself. Humanity may belong to that fragile interval. A brief moment when the universe became aware of its own structure before silence reclaimed everything. That thought carries an almost unbearable loneliness, because it means the cosmos is not simply expanding physically. It is drifting toward isolation cognitively. Future civilizations may not only lose contact with distant galaxies, they may lose access to truth itself. Entire branches of cosmology could become impossible to discover. Scientific understanding may shrink alongside the observable universe until reality appears far smaller than it truly is. The emptiness of space will erase not only matter, it will erase perspective. And perhaps that is the deepest horror hidden inside cosmic isolation. Human beings define themselves partly through context. We understand our planet because we compare it to other worlds. We understand stars because we observe billions of them. We understand cosmic evolution because the larger universe remains visible around us. But isolation destroys context. Without connection, understanding contracts inward. The universe becomes provincial, small, amnesiac. Imagine a civilization born trillions of years from now inside a lone galaxy, drifting through darkness. Their astronomers search the sky and find almost nothing beyond their local stars. No evidence of expansion, no distant galaxies, no cosmic background radiation. To them, the universe may appear static and eternal. The greatest discovery in cosmological history, that reality once emerged from a hot, expanding beginning, could become permanently unknowable. The universe itself will have hidden the evidence. This realization introduces a strange emotional reversal. Modern humanity often feels insignificant because the universe appears so vast and populated. Billions of galaxies make human existence seem tiny by comparison. Yet future civilizations may experience the opposite condition entirely. Their cosmos may appear empty enough to place them psychologically at the center of everything visible. Not because they are central, but because isolation has erased everything else. The expansion of emptiness changes not only physics, but meaning. And over even longer timescales, the loneliness deepens further. Stars will eventually exhaust their fuel supplies. New star formation will slow dramatically as galaxies consume their remaining gas. The bright era of stellar activity currently filling the cosmos will gradually fade into darkness. White dwarfs, neutron stars, and black holes will dominate the remnants of once luminous galaxies drifting through endless space. The universe will grow colder, dimmer, quieter. The great cosmic ecosystems that once produced life and awareness will slowly shut down one system at a time. Not through violence, through exhaustion. And throughout all of it, the void continues expanding. That may be the most haunting truth of all. Cosmic emptiness does not rush, it does not rage. It simply waits while distance increases and structures decay naturally over time. The universe does not need to be destroyed dramatically if isolation itself eventually makes complexity impossible. In that sense, cosmic voids represent more than regions of space. They represent the future, a preview of what reality becomes once connection disappears completely. And as the universe drifts toward that isolated state, another unsettling realization emerges. Perhaps humanity's greatest privilege is not intelligence itself. Perhaps our greatest privilege is timing. We exist during the rare moment when the universe is still visible enough to understand. The galaxies still shine across cosmic darkness. The evidence of creation still surrounds us. Reality remains interconnected enough for consciousness to map the larger structure of existence. But that window will not remain open forever. The silence is growing. The distances are widening. And somewhere trillions of years ahead, future observers may stare into a nearly empty sky without ever knowing that the universe was once filled with light. Which raises an even deeper question. If cosmic isolation eventually erases not only matter, but memory itself, then what truly survives at the end of the universe? At first glance, black holes and cosmic voids appear to be complete opposites. One represents overwhelming concentration. The other represents overwhelming absence. Black holes are regions where matter collapses inwards so violently that spacetime itself tears into extreme curvature. Cosmic voids are regions where matter becomes so sparse that galaxies nearly vanish altogether. One crushes reality into density, the other stretches reality into emptiness. And yet, both force humanity toward the same terrifying realization. The universe becomes most dangerous at its extremes. For decades, black holes dominated humanity's imagination because they feel like cosmic predators. Their danger is visible, dramatic, immediate. A black hole traps light, bends time, and destroys anything crossing its event horizon. Even their appearance evokes instinctive fear, dark centers surrounded by distorted halos of burning matter. They resemble monsters, and human beings understand monsters. Evolution prepared the human brain to recognize active threats. Predators chase prey, storms announce themselves with violence, fire spreads visibly across landscapes. Our nervous systems evolved around dangers that move, attack, and destroy quickly. Fear works best when the threat has a shape. Black holes provide that shape perfectly. Cosmic voids do not. A void possesses no surface, no visible boundary, no central object dominating the darkness. It does not roar, collapse stars, or pull civilizations inward. Most of the time, a void appears almost invisible against the larger structure of the cosmos. Even astronomers discovered them only after mapping galaxies across enormous distances and noticing what was missing. Voids are terrifying precisely because they lack obvious behavior. Their danger emerges gradually, silently, and psychologically. Human beings struggle far more with invisible threats than visible ones. Consider the difference between a predator and isolation. A predator creates immediate terror because the danger is direct. You can fight, flee, or react. Isolation feels different. It unfolds slowly enough that the mind often adapts before recognizing the damage occurring. Relationships weaken gradually. Civilizations decay over generations. Ecosystems collapse through subtle imbalance rather than sudden catastrophe. Cosmic voids operate according to that second form of destruction. Black holes consume locally. Voids erase globally. A black hole may destroy a star system, perhaps even alter the evolution of a galaxy, but the surrounding universe continues functioning normally. Matter elsewhere still forms stars. Galaxies continue colliding and evolving. The cosmos remains structurally alive around the damage. Voids threaten something larger. They expand. They separate. They slowly dismantle connection across cosmic scales. And unlike black holes, whose effects remain confined to specific regions, voids can span hundreds of millions of light years. Entire galactic superclusters could disappear inside some of these empty regions without significantly reducing the darkness surrounding them. That scale changes the emotional meaning of danger entirely. Human beings intuitively fear concentrated destruction because concentrated destruction resembles violence. But the universe may ultimately be shaped more profoundly by absence than by impact. A black hole distorts spacetime intensely within limited boundaries. A void reshapes the geometry of the cosmos itself over incomprehensible distances. One bends light. The other isolates it. One traps matter. The other prevents matter from interacting at all. And over billions of years, that distinction becomes existential. Black holes are finite objects. Even the largest eventually evaporate through Hawking radiation across unimaginable timescales. They appear eternal only because human lifespans are too short to witness their slow disappearance. But according to modern physics, black holes themselves are temporary. Voids may not be. As dark energy accelerates cosmic expansion, emptiness continues spreading across the universe. Galaxies drift farther apart, communication weakens, the cosmic web stretches thinner. In this sense, voids align more closely with the long-term direction of cosmic evolution itself. They are not interruptions inside reality. They may represent reality's final state. This is where the comparison becomes deeply unsettling. Black holes symbolize violent endings. Voids symbolize inevitable endings. Human beings emotionally prefer catastrophes because catastrophes feel meaningful. An asteroid impact, a supernova, a collapsing star. These events create narratives with causes and consequences dramatic enough for the mind to process. Violence gives destruction a kind of temporary clarity. But emptiness offers no climax. No enemy. No final battle. Only gradual disappearance. That may be why cosmic voids feel philosophically colder than black holes ever could. A black hole destroys through overwhelming presence. A void destroys through indifference. It does not attack galaxies directly. It merely allows distance and entropy to slowly dismantle connection until vitality fades naturally into silence. In that sense, voids resemble time itself. Aging rarely destroys suddenly. Civilizations rarely collapse overnight. Even memory fades gradually rather than instantly. Some of the most powerful forces in existence act so slowly that intelligent beings struggle to emotionally register them while they unfold. The universe appears to operate similarly. Its greatest transformations may occur not through explosive moments, but through subtle changes accumulating across billions of years. And this reveals something important about human psychology. We evolved for survival inside short timescales. Ancient humans feared predators because predators threatened immediate death. Fear became tied to motion, violence, and visible danger because those threats mattered most biologically. But cosmological threats operate differently. The universe reshapes itself across durations far beyond evolutionary intuition. Human minds instinctively underestimate processes unfolding slowly because no organism naturally evolved to perceive billion-year transformations emotionally. Yet those slow processes may ultimately dominate reality. Continents drift slowly enough that humans perceive them as stationary, despite their constant movement. Stars evolve so gradually that ancient civilizations believed the heavens were eternal. Cosmic expansion itself remained invisible until modern instruments revealed galaxies drifting apart across immense distances. The most important forces in existence often hide behind patience. And perhaps nowhere is that more evident than in the contrast between black holes and voids. A black hole announces itself dramatically. A void quietly changes the universe around it until the consequences become irreversible. One resembles death by violence. The other resembles death by forgetting. This difference carries profound philosophical implications. Human civilization defines meaning partly through connection. Science depends on the ability to observe distant galaxies. Memory depends on continuity across generations. Consciousness itself emerges from networks of interacting systems, exchanging information continuously. Existence becomes meaningful because structures remain connected strongly enough to sustain complexity over time. Voids interrupt that process. They increase distance. They weaken interaction. They isolate systems until understanding itself begins fragmenting. And eventually, if cosmic expansion continues indefinitely, even knowledge of the wider universe may disappear entirely from future civilizations trapped inside isolated galaxies. Black holes consume matter. Voids consume context. Which is more dangerous? That question may not possess a simple answer because the two threats operate across fundamentally different dimensions of reality. Black holes challenge survival physically. Voids challenge survival cosmologically. One threatens objects, the other threatens structure itself. And perhaps that distinction explains why the universe increasingly appears dominated not by visible monsters, but by invisible processes hidden inside the vacuum of space. The deeper humanity studies reality, the more existence begins resembling a temporary balance between opposing forces. Gravity gathers matter together while expansion separates it. Stars create complexity while entropy dissolves it. Consciousness emerges briefly between immense eras of cosmic darkness before fading once more into silence. The universe is not static. It is becoming. And what it is becoming may belong less to matter than to emptiness. That realization forces humanity toward one final unsettling possibility. If voids ultimately represent the future direction of the cosmos, then perhaps emptiness is not merely an absence within reality. Perhaps emptiness is the foundation beneath reality itself. And once that idea emerges, science begins drifting toward questions that sound less like physics and more like philosophy. At the edge of every great scientific discovery, philosophy returns. Not because science fails, but because eventually every equation leads toward questions mathematics alone cannot fully answer. What is reality? Why does existence emerge at all? Why does consciousness appear inside a universe seemingly dominated by emptiness, entropy, and indifferent physical laws? And perhaps most unsettling of all, why does the vacuum of space feel strangely fundamental to everything? For most of this documentary, cosmic voids have appeared as physical structures, enormous regions where matter becomes sparse and galaxies drift apart into darkness. Modern cosmology explains them through gravity, expansion, and the distribution of matter across spacetime. From a scientific perspective, voids are natural consequences of cosmic evolution. But human beings rarely stop at physical explanations. We search for meaning inside patterns. And the deeper scientists investigate emptiness itself, the harder it becomes to ignore the strange philosophical territory surrounding the vacuum of space. Because modern physics increasingly suggests that emptiness is not simply the absence of existence. It may be the foundation beneath existence itself. That idea appears repeatedly across multiple fields of thought, from quantum mechanics to information theory to ancient philosophical traditions. Different disciplines describe it differently, yet all circle around the same unsettling possibility. Reality may emerge from something far stranger than matter alone. Quantum theory already transformed the vacuum into an active system filled with fluctuations, hidden energy, and probabilistic behavior. Empty space is not truly empty. Particles emerge from it temporarily. Fields vibrate invisibly within it. Even the structure of spacetime itself may fluctuate beneath the smallest observable scales. In other words, the vacuum behaves less like nothingness and more like potential. And potential changes the emotional meaning of emptiness completely. Classical physics imagined reality as a universe of objects moving through passive space. Matter came first, space merely contained it. But quantum mechanics hints at something almost inverted, that invisible fields and underlying informational structures may be more fundamental than physical objects themselves. Matter could be secondary. The vacuum could come first. This realization naturally pushes some thinkers toward deeper philosophical questions. If particles emerge from quantum fields fluctuating inside empty space, then where does structure itself originate? Why does reality possess laws capable of generating stars, galaxies, chemistry, biology, and eventually conscious observers? No one truly knows. And in that uncertainty, speculative ideas begin to emerge. One of the most controversial involves quantum consciousness theories. These theories vary enormously, and many mainstream scientists remain skeptical of them. But broadly speaking, they explore whether consciousness might possess deeper connections to quantum processes than currently understood. Some researchers suggest the brain may exploit quantum coherence in subtle ways. Others speculate that consciousness itself could emerge partly from informational processes woven into the fabric of reality. Most of these ideas remain highly debated, with little definitive evidence supporting grand conclusions. Yet the fascination persists because quantum physics already destabilized humanity's ordinary assumptions about observation itself. At microscopic scales, measurement changes outcomes. Possibilities collapse into definite states only through interaction. Reality appears strangely dependent on relationships between observer and system, in ways classical physics never anticipated. This does not mean consciousness magically creates reality, despite popular misunderstandings. But quantum mechanics undeniably revealed that observation occupies a far stranger role in physics than earlier models suggested. And once that door opened, philosophical speculation followed naturally. Could consciousness represent something more fundamental than a temporary biological accident? Could awareness emerge from deeper informational structures embedded within the universe itself? Could the vacuum contain hidden properties humanity still barely understands? Science does not currently provide clear answers to these questions. But the questions themselves refuse to disappear. Information theory pushes the mystery even further. Modern physics increasingly treats information as a foundational aspect of reality. Black hole research, quantum computing, and thermodynamics all suggest that information behaves almost like a physical substance woven throughout the cosmos. Some physicists even argue that spacetime itself may emerge from deeper informational relationships hidden beneath observable reality. If true, then the universe resembles less a collection of physical objects and more a vast informational process unfolding across spacetime. And where does all of this unfold? Inside the vacuum. Inside the silent architecture of emptiness itself. This idea begins sounding strangely similar to ancient philosophical traditions that viewed emptiness not as meaningless absence, but as the source from which all form emerges. Certain Eastern philosophies described emptiness as fertile rather than barren, a dynamic field of possibility underlying existence. Even some Western metaphysical traditions treated the void as foundational rather than nihilistic. Thousands of years before quantum mechanics, human beings already sensed something paradoxical about nothingness. That intuition now returns in modern physics through entirely different language. The vacuum is not dead. The vacuum generates. And perhaps nowhere does this convergence between physics and philosophy become more provocative than in simulation hypotheses. The simulation idea suggests reality could resemble a computational system generated by deeper informational structures beyond observable spacetime. While often sensationalized online, the serious philosophical version of the hypothesis does not necessarily claim the universe is literally a video game. Instead, it questions whether physical reality might emerge from underlying mathematical or informational rules analogous to computation. Again, there is no scientific evidence proving such ideas. But they persist because the universe increasingly behaves in mathematically strange ways. Reality appears quantized at fundamental levels. Information limits exist throughout physics. Space, time, and matter may not be continuous in the ways humans intuitively imagine. And once philosophers begin asking what lies beneath observable reality, the vacuum naturally becomes central again. Because beneath every galaxy, every atom, every conscious mind, there is emptiness. Or at least something we call emptiness because human language lacks better words. This is where the documentary enters its most delicate territory, balancing scientific credibility against existential wonder. It is important to remain honest. No current evidence suggests cosmic voids possess consciousness, intention, or mystical awareness. They are physical regions shaped by gravity, expansion, and cosmic evolution. Science demands caution against projecting human meaning onto natural phenomena. And yet, human beings cannot help searching for meaning anyway. Because the universe itself invites the question, why should reality emerge from quantum fluctuations at all? Why should mathematics describe existence so precisely? Why should consciousness arise inside a cosmos apparently dominated by cold emptiness? No equation fully answers those questions. The deeper science advances, the the more reality begins resembling a strange intersection between structure and mystery. Physics explains mechanisms with extraordinary precision, yet the foundational nature of existence remains profoundly unresolved. And perhaps that unresolved space matters philosophically. For centuries, humanity imagined emptiness as negation. A void represented absence, meaninglessness, or non-existence. But modern cosmology increasingly suggests something almost opposite. The vacuum contains energy, quantum fields, hidden instability, potential for creation and destruction alike. The emptiest regions of the universe may actually be among the most fundamental. That realization changes the emotional symbolism of cosmic voids entirely. Maybe voids are not merely dead regions scattered between galaxies. Maybe they reveal something deeper about the architecture of reality itself. Not conscious in a human sense, not mystical in a supernatural sense, but foundational. The visible universe, stars, galaxies, civilizations, thoughts, may emerge temporarily from deeper structures hidden within the vacuum before eventually dissolving back into cosmic silence again. In that sense, emptiness stops feeling secondary. It becomes primary. And suddenly, the universe appears profoundly different than humanity once imagined. Matter no longer occupies center stage. Consciousness no longer appears permanently secure. Instead, reality resembles a brief flowering of complexity, suspended inside an ocean of deeper emptiness, stretching across space and time. A temporary awakening inside the void. And perhaps that is why cosmic emptiness feels so emotionally unsettling. Not because it is lifeless, but because it forces humanity to confront the possibility that existence itself may be fragile, temporary, and emergent from foundations we still barely understand. The deeper we study the vacuum, the less nothing it becomes. And the more mysterious reality itself appears. Which leads toward one final question, hidden beneath everything explored so far. If emptiness shapes the destiny of the cosmos, if the vacuum underlies matter, expansion, and even the possibility of awareness itself, then what does that ultimately say about humanity's place inside the universe? Are we separate from the void? Or are we simply another temporary pattern emerging from it before returning once more to silence? Every civilization eventually asks the same question. How does it all end? Ancient cultures imagined apocalypses shaped by floods, fire, divine judgment, or eternal cycles of destruction and rebirth. Modern science replaced mythology with cosmology, but the emotional question never disappeared. Humanity still wants to know whether the universe possesses a final chapter, and if so, what survives when it arrives. The unsettling answer emerging from modern physics is this: probably very little. Because the deeper scientists study cosmic evolution, the more existence itself begins resembling a temporary interruption between immense eras of darkness. Everything humanity has ever known, stars, planets, oceans, civilizations, memories, consciousness, may occupy only a brief moment inside a universe drifting slowly toward emptiness. And perhaps the most haunting realization of all is that even the universe's greatest monsters may vanish long before the darkness does. For billions of years, stars have dominated cosmic history. Inside their burning cores, hydrogen fused into heavier elements, generating the light and chemistry necessary for planets and life. Every atom in the human body was forged inside ancient stars that lived and died before Earth even existed. Humanity emerged because the universe once burned brightly enough for complexity to flourish. But stars are temporary. Every star is slowly consuming finite fuel reserves. Some die violently as supernovas, others fade quietly into white dwarfs. Massive stars collapse into neutron stars or black holes. Yet regardless of how large or powerful a star appears, every one eventually reaches the same conclusion: exhaustion. And over unimaginable spans of time, the universe itself will begin running out of starlight. This marks the beginning of one of cosmology's most haunting eras, the gradual transition toward heat death. Heat death does not resemble an explosion or collapse. It is not dramatic in the human sense. Instead, it represents the slow movement of reality toward maximum entropy, a state where energy becomes so evenly distributed that meaningful structure and activity can no longer persist. The universe does not die violently. It simply grows cold. Imagine a campfire slowly fading through the night. At first, flames roar brightly, then the wood weakens, embers dim. Heat disperses silently into surrounding darkness until eventually nothing remains but cold ash beneath an empty sky. Heat death scales that process across the cosmos itself. Trillions of years from now, star formation will largely cease as galaxies exhaust the gas required to create new suns. Existing stars will gradually burn out one by one. The brilliant galaxies currently filling the night sky will become graveyards populated mostly by stellar remnants drifting through darkness. The universe will enter an age dominated not by light, but by leftovers. White dwarfs, neutron stars, black holes, and emptiness between them growing wider forever. Yet even this era is not eternal. Because black holes, despite their terrifying reputation, are temporary too. Stephen Hawking's discovery of Hawking radiation revealed that black holes slowly lose energy over incomprehensible timescales. Tiny quantum effects near the event horizon gradually cause them to evaporate particle by particle into surrounding space. The process is unimaginably slow. A supermassive black hole may require more years to disappear than there are atoms inside entire galaxies. But eventually, given enough time, even the largest black holes fade away completely. This creates one of the strangest emotional reversals in all of science. Black holes once seemed like eternal cosmic prisons. Now physics suggests they may outlive stars, galaxies, and civilizations, only to vanish themselves eventually into emptiness. The monsters disappear too. And once they do, the universe enters something almost impossible for the human mind to emotionally process. Darkness without structure. No stars. No galaxies. No black holes. Only sparse particles drifting across expanding spacetime approaching temperatures near absolute zero. Reality itself becomes thin, quiet, almost featureless. This is the classic vision of heat death, a universe where entropy has erased complexity so thoroughly that meaningful processes become nearly impossible. No new structures emerge because usable energy no longer exists in sufficient concentrations to sustain them. Time continues, but nothing significant happens anymore. And yet, even this may not represent the universe's final fate. Some cosmologists fear something even stranger, the Big Rip. The Big Rip emerges from one terrifying possibility, hidden within dark energy. If the force driving cosmic expansion grows stronger over time, rather than remaining constant, then eventually expansion itself could overpower every binding force in existence. Galaxies would separate first, then galaxy clusters, then stars from galaxies. Eventually, planetary systems would be torn apart. Gravity would fail to hold worlds in orbit. Matter itself would unravel as expansion overwhelmed electromagnetic and nuclear forces. Atoms would disintegrate. Spacetime would rip structure apart completely. The terrifying aspect of the Big Rip is not merely destruction, but inevitability. No fortress could survive because the force causing the catastrophe operates within spacetime itself. Reality would not collapse inward. It would dissolve outward. Everything separated from everything else until structure became impossible. And somewhere beyond even these scenarios lies the possibility explored earlier: vacuum collapse. Unlike heat death or the Big Rip, vacuum decay would not require trillions upon trillions of years. It could happen tomorrow, or billions of years from now, or never. If the universe truly exists in a false vacuum state, then reality itself remains balanced atop hidden instability permanently. One quantum fluctuation could rewrite the laws of physics instantly. No gradual decay. No final warning. Just sudden replacement of the universe itself. Compared to heat death, vacuum collapse feels almost merciful in its speed. Heat death forces the cosmos through endless eras of isolation and exhaustion before darkness finally dominates completely. Vacuum decay erases everything immediately. And yet both possibilities point toward the same conclusion. Structure is temporary. This realization becomes emotionally overwhelming once viewed across the entire history of the cosmos. For billions of years before stars formed, the universe existed as darkness filled with hot plasma and expanding spacetime. Then came a relatively brief era of light, chemistry, galaxies, and consciousness. Eventually, according to every major cosmological model, darkness returns once more. Humanity exists inside the middle. A narrow, illuminated interval, suspended between two immensities of emptiness. That perspective fundamentally changes the emotional meaning of existence itself. Civilizations often imagine themselves progressing toward permanence, building monuments, preserving knowledge, expanding across planets. Yet cosmology suggests permanence may not belong to matter at all. Everything assembled eventually disperses. Everything burning eventually cools. Everything connected eventually drifts apart. Even atoms may not survive forever. Some grand unified theories predict proton decay, meaning ordinary matter itself could slowly disintegrate across absurdly long timescales. If true, then eventually every remaining particle structure in the universe may dissolve into radiation and fundamental remnants drifting through darkness. The universe slowly forgets itself. And perhaps the strangest part is how indifferent the process appears. No cosmic judgment accompanies heat death. No moral purpose drives expansion. Stars do not burn out tragically. Black holes do not evaporate angrily. The universe simply evolves according to physical laws, unconcerned with meaning, memory, or survival. This indifference terrifies human beings because consciousness naturally searches for permanence. We preserve photographs because we fear forgetting. We build civilizations because we fear disappearance. We create philosophies and religions because the human mind resists accepting transience completely. Yet the cosmos may fundamentally operate through impermanence. Not as cruelty, simply as nature. And still, there is something strangely beautiful hidden inside that realization. Because if existence is temporary, then awareness becomes extraordinarily precious. Humanity emerged during the brief era when stars still shine brightly enough for life, galaxies remain visible enough for discovery, and the universe has not yet dissolved into silence. Conscious observers exist during the narrow chapter when reality remains complex enough to wonder about itself. That may be one of the rarest conditions imaginable. A universe becoming conscious temporarily before darkness returns again. And perhaps that is the final emotional contrast underlying everything explored throughout this documentary. Human beings feared black holes because they appeared eternal and unstoppable. Yet black holes may evaporate long before the deeper emptiness surrounding them disappears. The void outlasts the monsters. Silence survives longer than violence. Darkness remains after every structure fades away. The universe belongs less to matter than to time. And time, ultimately, appears loyal to emptiness. Which leads toward the final question, hidden beneath every scientific theory discussed so far. If everything eventually disappears? If stars die, galaxies drift apart, black holes evaporate, and even memory itself dissolves into cosmic silence. then what does it truly mean that consciousness existed here at all, even briefly, inside the darkness? Here's the final cinematic conclusion section for your documentary. Humanity has always feared monsters. We feared predators hiding in forests long before we understood the stars. We feared storms because they shattered the sky with violence. We feared the ocean because its depths concealed unseen dangers beneath the surface. Fear became tied to visible threats, dramatic events, and catastrophic endings because evolution prepared us to survive immediate danger. And so, when humanity discovered black holes, we instantly recognized them as cosmic monsters. Darkness consuming light. Gravity crushing reality. Invisible predators wandering through space-time. Black holes gave shape to our oldest fears. But throughout this journey across the universe, something stranger slowly emerged from the darkness. The greatest threat in the cosmos may not come from violent objects at all. It may come from emptiness. Not because emptiness attacks us. Not because the void possesses intention or malice. But because the universe itself appears to belong increasingly to silence, distance, and separation. Galaxies drift apart, stars burn out, light fades across expanding spacetime. Even black holes, once imagined as eternal destroyers, may eventually evaporate into darkness themselves. The monsters disappear. The emptiness remains. And perhaps that realization unsettles us so deeply because cosmic voids mirror something profoundly human. Every life exists between two unknowns. We emerge briefly from darkness without fully understanding why, surrounded by a universe vast enough to humble every certainty we have ever created. Human civilization fills the silence with stories, discoveries, religions, equations, music, and meaning because consciousness instinctively resists emptiness. We search for permanence in a reality where everything appears temporary. Yet maybe the universe was never promising permanence at all. Maybe impermanence is the point. Because stars shine only because darkness surrounds them. Galaxies become beautiful precisely because they are rare islands of structure inside overwhelming emptiness. Consciousness feels miraculous because the universe appears almost entirely silent beyond the fragile worlds where awareness briefly awakens. Without emptiness, light would mean nothing. Without silence, consciousness would carry no wonder. This is the strange emotional reversal hidden beneath everything modern cosmology has revealed. At first, the void appears terrifying because it represents absence, isolation, the eventual fading of structure and memory across cosmic time. But slowly, another perspective begins to emerge. The emptiness of the universe is also what allows meaning to exist at all. A universe completely filled with noise, matter, and endless activity would contain no contrast, no rarity, no fragile moments suspended against oblivion. Human beings treasure life precisely because life is temporary. We value connection because separation exists. We look at the stars with awe because the surrounding darkness is so immense. The void does not merely threaten meaning. It creates the conditions that make meaning possible. And perhaps nowhere does that truth become more overwhelming than in the realization that humanity exists during an extraordinarily brief moment in cosmic history. We were born during the era when stars still burn brightly enough for life, when galaxies remain visible across deep space, and when the universe has not yet expanded into irreversible isolation. Right now, the cosmos is still awake enough to understand itself. Through us, that may be one of the rarest events imaginable. Atoms forged inside ancient stars gathered together long enough to become conscious. The universe evolves structures capable of looking outward and asking questions about existence itself. Across billions of years of cosmic evolution, matter briefly became aware. Not forever, briefly, and perhaps that brevity makes it beautiful. One day, the galaxies will fade beyond visibility. One day, stars will die. One day, even black holes may disappear into thin radiation drifting through endless darkness. The cosmic web itself may unravel into isolated fragments separated by impossible distances. Silence may reclaim the universe completely. But for now, against every scale of emptiness surrounding us, consciousness exists. For now, there are beings capable of wondering, capable of sphering, capable of looking into the void and finding not only terror, but beauty. Because maybe the final lesson hidden inside cosmic emptiness is not that humanity is insignificant. Maybe it is the opposite. Maybe awareness itself becomes more precious inside a silent universe. A single conscious moment may matter more in a cosmos dominated by darkness than it ever could inside a universe overflowing with certainty and permanence. The rarity of existence gives it weight. The fragility of life gives it meaning. And somewhere between the stars and the void surrounding them, humanity continues asking impossible questions. Questions the universe may never fully answer. What is consciousness? Why does reality exist at all? Why is there something instead of nothing? Science may continue pushing deeper into the structure of spacetime, quantum fields, and cosmic evolution for centuries to come. New discoveries will emerge. Old theories will collapse. Humanity's understanding of the cosmos will continue evolving. But perhaps some mysteries will always remain beyond the edge of comprehension. Not because the universe is hiding answers from us, but because wonder itself may be part of what it means to exist. And so, in the end, the emptiest regions of space become more than astronomical structures. They become mirrors. Mirrors reflecting humanity's deepest fears about mortality, isolation, and uncertainty. Mirrors forcing us to confront the fragile temporary nature of existence itself, but also mirrors revealing something extraordinary, that even in a universe drifting slowly toward darkness, meaning can still emerge. Light can still emerge. Awareness can still emerge. The void may surround us, but inside that vast cosmic silence, stars continue burning. Galaxies continue turning. And for one impossibly brief moment in the history of the universe, humanity opened its eyes and looked back into the darkness. Not with complete understanding, but with wonder.